3D printers have reached a point where more and more new models come with multicolor printing capabilities. However, there may be reasons to look for an alternative approach. You may already have a 3D printer you are satisfied with, don't have the space for another one, don't want to spend the hefty price tag of $1,000 to $1,500 these advanced multicolor-ready 3D printers often come with, making them out of reach for many of us, or simply don't want to bind yourself to a specific brand. CoPrint wants to close this gap with the ChromaHead KCM-Set, a modular solution allowing many 3D printers to print up to 20 colors. The compatibility list provided on the CoPrint website lists the models for which compatibility has been tested. Still, at least for the KCM-Set, it should work with almost any Klipper-based 3D printer as long as you can modify its configuration files. In this video I show you how to convert a single color Creality K1 into a 4-color capable 3D printer using the base KCM-Set I have here. For any other Klipper-based 3D printer, the installation should be almost similar. I encountered problems during the conversion, some caused by my impatience, like this destroyed build plate, or the ChromaHead breaking after a few successful prints, leading to a burnt PCB like this one. But I provide tips that may help prevent and solve these problems. Watch the complete videos so you don't miss them. You will also see why I'd rather continue using the KCM with one of my other 3D printers instead of the K1. First, let's see what you get with the KCM-Set. The biggest box contains the Klipper Chroma module, referred to as KCM module for the rest of the video. We also get a 24 volt 5A power adapter and cable and USB-A to USB-C cable to connect your 3D printer, as we will see later. In the next box is the ChromaHead. It's what approaches to be one solution for all, because it will replace your 3D printer's printhead to provide what's necessary to print with multiple colors. Then there's the 8-in-1 module to feed the filaments into the ChromaHead. We don't need the metal part for the K1, however, it is required when installing the ChromaHead on a V-slot 3D printer like the Ender V3 or similar. The box contains a cable to connect the KCM and the ChromaHead that provides power for the head and communication between them. Then some small parts, 4 screws to mount the ChromaHead, a few tools and some fittings to secure the PTFE-Tubes, which will be pushed into the 8-in-1 module. Finally, the last 4 boxes. Each contains a CX1 extruder, a PTFE-Tube, a cable to connect the extruder with the KCM module, and some small screws. The metal sheet and the T-nuts aren't needed for the K1. The 3D printer you want to convert should run Klipper. I enabled root access on the Creality K1. Watch my video Unlock your Creality K1's full Klipper potential, where I show the process in detail. An adapter plate is required to install the ChromaHead on the 3D printer. I also recommend printing the parts for the extruder mount. Unless you have a second 3D printer, you should print both before uninstalling the old printhead. I printed the STLs provided for the K1 in PLA CF. Though the extruders can get a little hot, I had no problems with it. Maybe PETG would be a better choice for the extruder holder. I don't have a proof of what caused my first ChromaHead stepper driver to burn. I may have gotten a bad batch of the ChromaHead, my K1's USB hub is faulty, or a combination of both. I assume the problem is not a general problem of the ChromaHead because I haven't seen or read of anyone else with such a massive failure. The few other reports I found were about less severe USB communication problems, but not a broken ChromaHead like mine. I got it replaced by warranty after contacting CoPrint support and showing them what happened. The documentation was one of the most criticized things when CoPrint started selling the ChromaHead KCM sets. At Formnext 2024 I was promised that they would work on the wiki content.
As we are updating every week actually.
It has improved a lot since, so time to check if one can get up and running by following their step-by-step guide. Before you start to uninstall the old printhead, you should make sure that you have rooted the K1, because you will run into a trap if you don't do so, which isn't mentioned in the wiki. You won't be able to access a menu to root your K1. Okay, Enough said, let's start the procedure. Start by removing the 2 screws of the cable chain holder on the back side. Then remove the one holding the cable chain to the print head. Now remove the 3 screws on the right side of the print head and then the 2 screws on the left, which hold the cover and the extruder motor. Once the screws are removed, you can remove the cover. Then disconnect the main cable from the control PCB. Be careful because the connectors are glued in. You may have to put the glue away, softening it using a heat gun. My cable is secured with a bracket, which I must also remove. Once the connectors from the cable chain are unplugged, you can move it to the back. We don't need it for the KCM set. Next, remove the cover from the extruder motor and pull the motor out. To remove the control board, loosen the 3 screws holding it. Then remove the thermistor and heater cartridge connector. Uninstall the Hotend by pulling off the silicon sleeve and removing the 2 screws holding it. To complete the disassembly of the Hotend, you have to take out the heatsink, which is held in place by the last 2 screws. To mount the ChromaHead, you need the adapter part that you printed beforehand. If you forgot to print the required parts, no worries. This is where PCBWay, this video sponsor, can help. Just upload the STL files of the needed parts, choose the material and get a quote instantly. Your professional looking 3D printed parts will be ready within 3 business days. PCBWay is also known for its high quality PCB and CNC machining services, making it your one-stop supplier for all your needs. You will find the link to the PCBWay website in the description. Take the adapter, put it in place and secure it using the 4 supplied screws. With the ChromaHead you also have some square nuts. Slide them into the slots on the sides of the adapter and use an Allen wrench to push them into position. Now take the ChromaHead, remove the front cover, position it on the adapter and use the 3 screws from the supply bag to fix it. Take the ChromaHead connection cable, plug it into the connector and use the 2 screws to hold it securely in place. Put the magnetic cover back on. To finish the ChromaHead installation, you can also mount the 8-in-1 adapter now. Next, let's prepare the extruder mount. The CX1 extruders come pre-assembled. We have to separate the extruder section from the stepper motor to mount them to the extruder mount. To do so, remove the 3 screws that hold them together and pull off the top. I have already prepared that for all my other extruder motors, so we can proceed with mounting them to the extruder mount. Position the stepper motor from the bottom, matching the hole with the connector facing outwards, and put the top part onto it. Fix it with the 3 screws and repeat the procedure for the remaining motors. And the last motor before we finish the extruder mount. Now mount the holders. I printed the extruder mount that uses the square nuts which slide into the slots on the sides. If you printed the version without the slots, then you have to use 3 mm nuts to mount the holders. Here's the finished extruder mount for 4 CX1 extruders ready to get on the K1. Then, to install the PTFE-Tubes, take them and push them into the CX1 extruder fittings. Now insert the black fittings into the holes of the 8-in-1 adapter. Next, push the PTFE-Tubes ends from the extruders into the fittings. To prevent the tubes from getting pushed out of the fittings, secure them using the blue clips. I use this PTFE-Tube organizer, which I designed after not being satisfied with the provided one, to hold the tubes together and, more importantly, keep the head cable away from the print area. I put a link to it in the description. I also labeled the 4 extruders and the KCM module's motor connectors with E0 to E3 from left to right. The labels help keep things clear when we configure Klipper. Then the extruders are connected to the KCM module using the motor cables according to the labeling. Let's finish the hardware setup by connecting the KCM module's USB cable, the ChromaHead's cable and the power adapter. Plug the USB-A connector into your K1 and the USB-C connector into the KCM module. Then plug in the ChromaHead's cable and finally the 24-volt power supply. If you appreciate this detailed guide and are ready to move on to the software, hit that thumbs up. It really helps support the channel. Let's assume your K1 is routed. Otherwise, you'll need to reinstall the stock Hotend to regain access. Open an SSH terminal using your preferred program, I use the Windows command prompt. Type SSH root add IP address and press enter. Accept the fingerprint and enter the password. Change to the Klipper directory by copying the command from the wiki, then run the helper script. If you don't see it or get an error, install it using the git command from the wiki. Once installed, rerun the helper script. You will see its main menu. Enter the installation menu by pressing 1, then install Nginx and Moonraker by pressing 1 again and accepting with yes. Wait for the installation to finish. Once you are back in the installation menu, press 3 to install the Mainsail UI. Press Q and enter to exit the helper script. Now, to install an updated version of Klipper, clone the repository. Copy the git clone command from the wiki and run it. Change into the newly created Klipper directory using the appropriate command. This step might seem awkward. Switching to a specific branch prevents updates. If you accidentally update later, reset it with the command provided in the wiki. Open a new browser tab and type the IP address of your printer, followed by 4409. Press enter to load the interface. Now download the Clippy target GZ file and upload it using the Mainsail interface. After uploading, switch back to the terminal to move and unpack the file. Use the vi command to modify the service file. Locate the py script line, copy it by pressing y twice, and then insert it by pressing p. Comment the original line with a hash and update the duplicate's path to data. Also, find the copy_config line and comment it out by placing a hash in front of it. Save the file with :wq. Now restart the Klipper service using the wiki command. Before we can use the new configuration, extract the contents of the configuration zip file. Then go to the Mainsail web interface, open the machine section and upload all extracted files. According to the wiki, no further configuration is needed if you're using only 4 colors and a base KCM set, but that's usually not the case. If the Mainsail interface shows a CP driver error, open the machine section and verify paths in the ChromaHead and KCM configs. To check the correct serial path for the KCM module, unplug the ChromaHead, click refresh and use the TTY ACM path shown. Then open the ChromaHead config file, connect your ChromaHead and press refresh. You should see another TTY ACM path. Update it in the file and comment out incorrect paths. Save and restart the firmware from the Mainsail interface. If successful, you will see the interface without errors. Don't forget to calibrate the probe. I once forgot about it and damaged a build plate. Home the printer, then go to the console in Mainsail and type probe calibrate. Use the buttons to move the build plate until you feel a drag on the paper. Then use the other buttons with smaller increments until you are satisfied and accept the new position. Save the settings with the save config command. Klipper will restart. Now is a good time to do the input shaping and PID calibration. In the console, enter shaper_calibrate and press enter to start calibrating the input shaper for the X and Y axis. Woo! What's that? Klipper immediately shuts down, showing an error. Luckily, I have the solution right at hand. CoPrint messed up updating the input shaper configuration for the K1, though the problem has been known for almost 6 months. To fix this, copy the appropriate section from the input shaper configuration provided in the general configs on the CoPrint GitHub page. Power cycle the K1 and the KCM module after changing the file. Now the shaper calibrate command works. When it finishes, it calculates the best input shaper values to use. Use save config to write them persistently to the printer configuration so that they reload when the printer is powered on. After the input shaper calibration, let's tune the PIDs for the print bed and the extruder. It's best to do when the printer is at room temperature. For the bed, enter PID calibrate heater equals heater bed, target equals 60. The bed will heat to 60 degrees Celsius, most likely overshooting that target. Then it cools down to 55 degrees Celsius. The heat-cool cycle will repeat several times. When done, the recommended PID parameters show up in the console. Save them to the printer config with save config. Next, tune the extruder's PID values. To start the calibration, use the command PID calibrate heater equals extruder target equals 220. Again, after a few cycles, you will see the recommended PID parameters for the extruder. Unfortunately, trying to save them using save config outputs an error. Klipper can only save config values for sections defined in the main printer config. The extruder section is defined and included in the ChromaHead config. Therefore, you have to set the values found for the PID parameters by editing the values in the ChromaHead config file. When done, you can do save and restart to make the new values active. The PID-Tuning helps to keep the chosen temperatures for the print bed and the extruder on point. To test if the extruders are connected correctly, heat the nozzle to at least 175 degrees Celsius. Then, in the extruder widget, select T0 and click Extrude. Check if the extruder that you assigned to be T0 moves. Repeat this for the extruders T1 to T3. If the extruders are not moving as you assigned them, reconnect them in the correct order. Next, load the filament. Pull the lever of the extruder and push in your filament until it reaches the top of the 8-in-1 module. Feed in the remaining colors the same way. To load the filament, heat the nozzle to the filament printing temperature. Then, in the macros widget, click the Set Filament Position macro. It's best to start with extruder T3. Click T3, then click Extrude. Repeat clicking Extrude until the filament comes out of the nozzle. Then click on Set. You should hear the filament cutter cutting and retracting the currently loaded filament. Next, click T2 to activate it. Click Extrude until the filament loaded in Extruder 2 comes out of the nozzle. Repeat the procedure with Extruder T1 and finally T0. That way you have loaded the filament in Extruder T0 and are ready for 3D printing. Update or install Orcaslicer by downloading the latest version from its GitHub page. On a new install, you see a setup wizard where you can select the CoPrint printer profile in the printer selection. If you updated Orcaslicer, create a new printer profile using the CoPrint profile. In both cases, open the profile settings and adjust the build plate size from 225 x 225 to 197 to 163. That's necessary because the ChromaHead is larger, which unfortunately reduces the available print size. Here I loaded a colored model for printing. I assigned the colors using the filament menu on the left. After slicing, the generated G-code can be exported and printed with the modified K1. "3D printing in color extends the already existing creative potential of these machines. The downside is that the printing times and the plastic waste produced increase drastically due to the need to purge the nozzle on each filament change. As you can see here, the ChromaHead's print quality is excellent. The color bleeding in the print can be addressed by adjusting the purge volumes in the slicer. Alright, let's wrap this up with some final thoughts on where these multicolor solutions stand, especially focusing on the CoPrint KCM-Set. Looking purely at the cost, the CoPrint KCM-Set is the most budget-friendly option at just $289 for 4 colors, undercutting both Bambu Labs AIM-S and Creality's CFS. If you are aiming for more colors, the CoPrint Chroma set becomes cheaper than the competition starting at 8 colors. As you scale up, CoPrint's price advantage becomes even more significant, offering up to 20 colors while the others cap out at 16. For instance, getting to 16 colors costs $736 with the KCM set, compared to nearly $1,200 for AIM-S or CFS. So, besides price, how does the CoPrint KCM set stack up? Let's compare the pros and cons to solutions like the AIM-S and CFS. On the pro side for CoPrint, first, cost effective. As we saw, it's cheaper initially, especially the KCM set, and the savings grow with more colors. Second, more colors. It supports up to 20 colors, beating the 16 color limit of AIM-S CFS. It has a wider compatibility. It works with any 3D printer running Klipper firmware, offering great flexibility beyond specific brands. The Chroma set also has a growing list for other firmwares. It has a modular head. The ChromaHead design makes replacing worn or broken parts easier. It has a quality hot end. It includes a respected Fairtus hot end. But there are cons to consider. It's not plug and play. Unlike the user-friendly AIM-S or CFS, the KCM set requires technical skill and knowledge of Klipper for setup and tuning. Second, you need a DIY filament management. You'll need to create your own spool holder solution, rollers or dryer boxes. The AIM-S CFS integrates this. Then the cable management. Things can get messy, particularly if you're expanding to many colors. The printhead is very heavy, around 460 grams, and bulky, potentially limiting the max print speeds and slightly reducing print volume on some machines. Support and documentation. While improving, support and documentation are still evolving and might feel incomplete at times. Hey CoPrint, if you're watching this, I'd really appreciate if you'd clean up your files and wiki pages so that it's easier to follow and that there are no errors. Then, early adopter issues. I ordered my KCM set on Kickstarter, and some of the early units had minor issues like power connection sparks or firmware bugs, though these are addressed. Ultimately, the CoPrint KCM-Set is a fantastic option if you are budget-conscious, comfortable tinkering with Klipper, need more than 16 colors, or want to add multicolor capabilities to a non-bamboo or Creality printer. However, suppose you prioritize a seamless plug-and-play experience with integrated filament handling and are already within the bamboo or Creality ecosystems. In that case, the AMS or CFS might be the simpler, albeit more expensive route. Choose the best solution for your budget, technical skills, and printing needs. If you're enjoying this content and want to stay updated on more 3D printing reviews, tips, and comparisons like this one, please take a second to like this video, subscribe to the channel if you haven't already, and don't forget that notification bell. I'm working hard to reach this channel's next milestone of 2,500 subscribers, and every single click helps us to get there and keep making videos for you. Huge thanks for sticking around and watching this comparison. I hope it helped clarify things. If you want to see more, check out some of my other videos right here. Maybe my interview with CoPrint at Formnext 2024 or my guide to unlock your K1's full Klipper potential. Thanks again, and I'll see you in my next video.